During the analysis of motion in last few videos, what we are really trying is to analyze the motion of an object. But what we are really doing is analyzing the motion of a particle or a point object. Now in this video, we will find why this concept of point object has been arise, when we actually can call an object to be a point object. Is it really mandatory for an object to be a point-like thing in order to call it to be a point-like object? And what are the complications that will arise due to this consideration and how to overcome it? Now see, when number of forces are acting over a body, then the body will going to have both translation and rotation. This translation along with rotation will call compound motion. Like what we are seeing in the following videos, that an asteroid is moving both with translation and rotation. And the only way to make the problem simple is to analyze this translatory motion and rotational motion separately. And that is what we can do by considering the object to be a point-sized thing. Because when the object is considered to be a point object, doesn't have any dimension. So it doesn't have any rotation also. So there is only translation. So now we can apply Newton's law and find out what is the acceleration in the body in his translatory motion. After that, we will define rotational motion of the body by considering its dimension, and we will find torque, which is analogous to the force in translatory motion, and we will find that when torque is applied over this body, the body will going to have rotation. So similarly, we will find different analogous parameters like what we are seeing in the translatory motion, and we will also define Newton's laws of dynamics applied to rotational motion by using these parameters. Like moment of inertia, it will play the same role as mass does in linear motion. So by considering the object a point, we are actually representing the motion of the object by a point. Later we will find that this point is nothing but the center of mass, that is a mathematical idealization. That means it is not necessary the point is to be physical particle. And we can only consider an object to be a point-like object when the dimension of the object is very much smaller than the distance what we are talking about. Like Earth is not a point object. We know that the radius of Earth is quite huge and it is about 6,400 kilometers. But the path which Earth is traveling around the Sun during its motion around the Sun is very much larger than the radius of Earth or the dimension of the Earth. So here we can consider Earth to be a point object. Hence we can say that when the dimension of object is very much smaller, that is irrelevant to the distance it covers, then we can call the object to be a point object. Now we cannot consider every kind of object to be a point object, because actually what we are trying is to represent the motion of the object by a point. So if different point of the object or different portion of the object moves in different direction and with different velocities, then we cannot represent the motion of the object by a single particle. So this will happen if the body is a deformable body. So it is mandatory that every portion of the object moves in same direction and with same velocity. Now this can only happen if the body is a rigid body. So that is why right now we are studying motion of a rigid body. Now in this respect we can differentiate between translatory and rectilinear motion. Although we should not differentiate between these two types of motion because they are not completely different kinds of motion. Later we will find that this rectilinear motion is a kind of translatory motion, and we can find it on the following example. Suppose we are going to study the motion of an object with respect to a reference frame O, X and Y, and we are going to study the motion of an object like this. Suppose this object is made up of constituent particles A, B and C. Also there is another reference frame O prime, X prime and Y prime attached with the body. Now suppose if the body moves from here to here in such a way that all of its constituent particles like A, B, C moves same distance in a given time, like what we can see that these three particles travels same distance in a given time, and also the coordinate frame attached with the body remains parallel to the external coordinate external reference frame, that means the main reference frame OXY, then this kind of motion is known as translatory motion. So we can say that as the as all the particles of body travels same distance in a given time, then that is why it is known to be a translatory motion. Also from the above motion we can see that the body is all the constituent particle is not only traveling same distance in a given time, but also the body is moving in a straight line path. Hence if the distance that is covered by the body is very much greater than the dimension of the body, then we can represent the motion of a body with the help of a point, and that point is center of mass. So suppose this is the point with the help of which we are going to represent the motion of a body, motion of this body actually. Then we can say that the body is a point object, and we can find that a point is actually moving in a straight line path. When a point moves in a straight line, when a point object moves in a straight line, then it is called rectilinear motion. So we can find that translatory rectilinear motion is a kind of translatory motion in which a point object moves along a straight line. But for translatory motion, two mandatory things is that all the constituent particles should cover same distance in a given time, and also the reference frame attached to the body remains parallel to the main reference frame. Now that can happen also when the particle travels in a path like this. Suppose this is another path which the body is going to follow. Now in this case we can see that although the constituent particles traveling same distance in a given interval of the time, but they are not moving in a straight line. Instead of this, they are moving in a curved path. So this kind of motion is also a translatory motion because all the constituent particles of the body, so this kind of motion is also a translatory motion because all the particles is moving covering same distance in a given time, but they are not moving in a straight line path. So this is called curvilinear motion. Here also we can see that the reference frame attached with the body remains parallel to the external reference frame or main reference frame. Therefore, the body is not rotating. This implies that the body is not rotating. Therefore, the motion of the body is completely a translatory motion. So what we have found that this translatory motion can be of two types. A body can achieve translatory motion in two ways. One is a rectilinear motion and the second one is a curvilinear motion. Now we have seen that this rectilinear motion is a kind of translatory motion in which every particle that constitutes the body moves same distance in a given time, but in a straight line path. And on curvilinear motion, we will find that every constituent particles by which the body is made up of travels same distance in a given time, but not in a straight line. Instead of this, we will find it to be travel in a curved path. That is why it is known to be a curvilinear motion. Also, this body can move in another way. Suppose that this body is moving in such a way that the reference frame which is attached with it do not remains parallel with the external reference frame. Now this kind of motion is obviously not a translatory motion because the body is rotating, because the reference frame attached with it not remains parallel to the external reference frame. That indicates the body is rotating. So it is a kind of rotating motion.